Hi, welcome to yet another Dogen release, version 1.0.26, Rio Bentiaba. So this was a bit of an uncommon release, I guess, in that it took quite a long time to come out. Tried to stick to 3 to 4 weeks. This was almost 6. There's a lot of stuff going on at the moment, so but nonetheless, it was quite an interesting release, and there's a lot of interesting stuff here. So let's have a quick look. So the first bit that we spoke about in the release notes was the Archetype Factories and Transforms. So what we'll do is I'll just do a quick sort of chat about the feature and what's going on. So what you can see here at the moment is the text model. I'm currently working on it. That's why this artifact has got a weird blue color. So in the past, as I explained in the release notes, we used to project the archetypes over to physical space only to one single archetype, and that was the transform itself. So just to recap, in our logical model we have a set of physical elements. One of those is the archetype. There's others. There's also facets, backends, parts, and the archetype itself. And in the past, this logical model element, the archetype, got projected to physical space, but it got projected just to to two single representations, to be fair. We needed the header and we needed the implementation. But that then meant that we had both the transform aspects of it, the model to text transform, as well as the factory aspects of it, all in one place, which doesn't really sound like the right thing to do. So what we've done with this release is we separated that into two different transforms, one for the factory and one for the transform itself. And of course we did the same thing for facets, backends and parts, because they all follow the same pattern. Now if you remember, we recently changed so that the stitch template is now an attribute here, and this is a bit painful until we move to a better representation such as org mode. So what we're doing at the moment is sadly we need to copy the file over to Emacs to have a look at the templates. So if I just paste this template here, what you can see here is the stitch template that goes along with that factory transform. And what you see in the factory transform, as you'd expect, is the template aspects related to generating the archetype. So as you can see here, we're creating the archetype, we're supplying the parameters and so forth of the archetype. And if I have a quick look at the code that gets generated from this, which probably is slightly more meaningful than a template itself. So if we go somewhere like types, in fact I'll probably just open it directly. So if I just choose something like archetype, I could choose something like the class header factory, for example. So you see, this is what this template generates. It generates, in effect, it just generates the archetype and all the relations that go along with it. These are the relations that we've worked on in this model, in this sprint, sorry. So you can see here it's just providing a very simple way to instantiate the archetype, giving all the labels and all the relations. It's very self-contained and only does one thing really. On the other side we have the transform aspects of it, which are just as they were before. So the C++ code generated for it contains all the nonsense related to generating the type itself. And you can see an example here. I mean, this is actually the class one, but it will be slightly different for an archetype, as you can imagine. So if I'd say, for example, take the archetype class header implementation class implementation transform. And as you can see, this is what I was alluding to in my release notes. It's actually quite difficult to navigate these names. It's not really ideal because there's so many similar names. It requires a bit of thinking. There is a logic to it, but it just still requires a bit of thinking. So as you can see here, we have there's actually some kind of indentation error here. We have the implementation of the transform for the transform. And what this is doing is that literally saying, well, because I'm an archetype, I'm a special type of meta model element, all I want whatever it is to the template that you've rendered for me. Other cases, of course, you would have a different template, but the archetype is a special case. And that is kind of more or less the gist of this split that we've done with the Archetype Factories and Transforms. The next item on our agenda was adding supports for CSV values in variability. So again, if we go back to our stitch area here in Emacs, if I could find it. So we can see here is an example of the sort of things you're going to end up seeing in elements. Again, I just pasted this in the MetaModel element because, like I said, at the moment it's very painful. So if I'm just going to do this again so you can see what I'm doing. If you take a class, any class, copy the comments, and then you can paste them in Emacs. Not entirely sure why my Emacs is a little bit slow. You can see here now that we now have a number of relation-related fields, and we just, for the life of us, we couldn't really figure out a way of just supplying these things without having more than one entry on the value. We tried very hard to create the relations as key value pairs and so on, but by the end of it we just concluded it was easier to just make them CSV values. In other words, we have the notion of the relation. In this case is a constant relation. The relation has some kind of type. In this case is a logical model element associated with it because it's a constant relation, and then it's got a target, which in this case is this archetype. And it's just easy to use a CSV value here. And what we were doing before, of course, is we were just taking this as a text value, splitting the text value and parsing it. And then we suddenly thought, well, actually, maybe it's the job of the variability subsystem to provide these kind of services, because we're really saying that the value that's being supplied in the metadata is a CSV value. So we added these new types of value, comma separated and comma separated collection. If you remember, we have a very simplistic value system here in variability. We try to make it really, really simple. That's why we only have things like text and text collection and things like that. So CSV follows the same pattern as text. There's a CSV collection, and there's a CSV value itself. You probably should really call these CSV rather than comma separated. I just didn't want to confuse things because this guy is already called value, and now it's going to be value here too, CSV. So I thought it would be easier to actually call it comma separated, but actually now on hindsight I think it is actually better to just call it CSV. So we might refactor that next sprint. But the gist of this now is that when you request a value from the variability subsystem, you can just ask for this value as CSV, and if everything was instantiated correctly, you then get a list of the strings that compose that CSV value. If it's a collection, it's in effect a list of those things, which makes life easier from the point of view of consumption of these values. Next, we shall talk briefly about relations between archetypes and the PMM. So, the PMM has grown, and the physical model in general has grown quite a fair bit with this release. So what we've done is we created a large number of classes related to modeling the relationships, which we use this like more mathematical term of relation. So as I explained in the release notes, we identified two key types of relations, constant and variable. I mean, we also have these hard-coded ones that enable you to bypass the entire system and then just add an include file. We haven't quite implemented those yet, but I think we will need these because not everything is covered by the modeling subsystem. But really the two ones I want to talk about are constant and variable relations. So the idea here is that we want to take all the relations that we've got, that we've sort of explicitly made use of in the templates, and we want to model these as a higher level relation. And as I showed a second ago, when we declare an archetype, we can declare the types of relations with it. And with this information, Dogen should hopefully be able to then reconstruct what's hard-coded in archetypes at present. So to compare the two approaches, at the moment here you can see an example of the hard coding we're doing, in that we explicitly say we have a relationship with this header file. Now this is all fine and dandy, of course it works, and it's been working so far, but the difficulty with this is that there is no concept at the modeling level that we now created a dependency between this model and this element, this logical element, and the artifact as well. So what we're trying to solve with this, by promoting this, by moving everything a level up, what we're trying to now say is, actually, it's a concern of the logical physical space, the relationships that may exist between archetypes. And in the future, once this is all implemented, you can even imagine you can extract the graph of relationships. It probably is a multigraph, I guess, because it's going to be a graph of graphs, showing the relationships between all the different archetypes superimposed between the physical and the logical space. As you can imagine, at the top you have the logical space, and this logical space projects to the physical space. And so the same thing happens with the graphs. You have a graph of relationships that exist in the logical space, and that graph of relationships then projects to the physical space. And the projection is just not one-to-one, so you have this much more complex graph generated in the physical space. And once you have that graph, then you can do all sorts of interesting things, like, for example, you can start to explore the relationships between archetypes and ensure that the configuration requested by the user actually is consistent with what's being instantiated in the graph. And so that's really kind of the future. However, it's quite a difficult thing to do, so it's taking us a while to get there. The second aspect in the physical model that we spent a lot of time coding was the Archetype Repository. So the Archetype Repository, which sits a little bit to the right of the relations in the model, was our attempt to decouple the physical aspects that we had scattered all over the place, the logical model and the text model and so on, and move everything over to the physical model. So for instance, we were handling enablement properties in the text model, and it was a cross between a logical representation and a physical representation, so it was really messy. So now we've removed all of that, and what you can see in the logical model now is the element just contains mainly logical things. We will move decorations to a slightly more suitable home in the text model, and the text model itself now is becoming really a text model. As you can see, it's almost bare now. So we're getting very close to the anticipated merge between this text model with the other text models, which is quite nice. And here you can see the logical physical representation in that we join the logical elements with the plane of the physical space. So what we've done then is we created this artifact repository, and we created a set of transforms that go along with it, which are these chaps here, the artifact repository population chain. And the idea now is that as you're taking a model from the logical space and you're trying to get it to the logical physical space in the text model, you have this intermediate step where you create the artifact repository. The artifact repository then runs all these transforms, and these transforms enable you to get the artifact in the right shape, such that it can then be converted into text. And then the text model then kicks in and then runs the model to text chain, which are just the text transforms. So it was, in the end, it was actually quite a sort of a obvious thing to do, I guess, once it was done, but it wasn't very obvious before we did it. And particularly, one thing that wasn't very obvious was the need for the planes in the physical space. And what we mean by this is that if you think of the logical physical space as a two-dimensional space composed of the physical dimension and the logical dimension, often we need to slice that space into a plane, and that plane is a point that contains a logical model element and all the archetypes that go along with that logical model element. And that's in effect modeled by this idea of an artifact set, which we have here. And the artifact set obviously belongs to a logical model element, and of course to a logical model meta element. And well, with this notion of the artifact set, we just carry that through, so that everywhere where we are slicing a plane, we are using exactly the same representation. So if I now go to the text model, what you'll see here is that this uses an artifact set. And if I go to the existing sort of legacy implementations, such as formatable, these are all things that need to go. This also uses the artifact set plane. And so it's used consistently across the code base now, instead of all sorts of hacks that we had before. And so with that we managed to implement the artifact repository with this approach using planes in all the transforms, and we moved all the sort of infrastructure that was scattered all over the place, such as enablement, over to the right location. And so this is much neater now. And with that now we are actually prepared to make use of relations. So what's going to happen now is that we're going to extend that artefact repository population chain with a set of transforms related to relations, and they're going to make use of all the stuff that we added here in order to generate the relations. That is in effect a refactoring of a lot of the code you see here to do with locations, inclusion expanders, directives, directive builders. Pretty much everything you see here will now be captured by this simplification of this modeling. And I think with that we probably reached the end of the presentation. So yeah, this is all we got for this sprint. It was quite a very interesting sprint. It was very hard, but it was very interesting. I suspect the next sprint will be probably not equally as hard, but will also offer some interesting challenges because we still are in the guts of this meta model. We've already had a large number of ideas. Unfortunately, this is one of the problems with Dogen. Every time you touch something, you have 10,000 ideas. So you had quite a lot of ideas for more refactorings and things needed to be cleaned up. So this sounds like the next sprint would also be quite exciting. But that's all we have for this sprint. Thanks very much for watching.